Welcome to Conversations with ATG Solutions, where we bring people from across the satellite communications industry together to have practical, honest conversations about what's happening in the industry. I'm Nicole Fields with ATG Solutions, and today we're talking about the future of satellite ground architecture, where it's headed, what's no longer working, and what operators are having to rethink as these systems grow more complex. We'll focus on two ideas that keep coming up in serious ground discussions: digital IF and virtualization. Not as buzzwords, but as real tools and, in some cases, real trade offs operators have to deal with when modernizing ground infrastructure. I'm joined by Ken Kwok, CTO at ATG Solutions, along with industry voices Rachel Jacobs and Ron Bush, who both work daily with ground systems from different angles. Ken Kwok brings experience from both the defense and commercial sides of SATCOM. He served as chief engineer for the SATCOM Gateway Office at DISA, helping to shape the next generation gateway architecture. He also led development and certification of GX Aero terminals at Inmarsat. Ken understands ground architecture from the network core all the way to the edge. And Rachel Jacobs is a mission advocate on the Aerospace and Satellite Solutions team at Amazon Web Services. She works closely with satellite and aerospace organizations on how virtualization, edge computing, and scalable infrastructure are applied in mission environments. And to round out the discussion, Ron Bush is a ground satellite architecture consultant with deep hands-on experience designing, integrating, modernizing real-world ground systems. His background includes network engineering, network operations, and program management at Hughes, Pan Am Sat, Intelsat, and ABS. He brings the practitioner's view of what actually works in deployment. So let's just start with the big picture. Before we dive into specific technologies, I think it'll be helpful to understand where ground architecture stands today and where the real pressure points are. So when you all look at today's ground systems, what do you see as the biggest limitation, both technically or operationally?
So I was at AFA Warfare Symposium a couple of weeks ago, and the message from senior leaders was consistent. Cyber pressure is constant, the spectrum is contested, and we need systems that keep working when things are jammed or attacked. The biggest limitation in today's ground architecture is that it was built for a quieter era, where upgrades were slow and change was rare. Today, the real gap is speed. We need ground that can adapt quickly, recover quickly, and be upgraded continuously, because space-enabled services now sit at the center of deterrence, homeland defense, and coalition operations. As General Saltzman pointed out at AFA Warfare Symposium, the Space Force is small but supports nearly every joint mission. So the only way to keep up is architecture that reduces operator workload, automates recovery, and makes updates routine.
Great insight from a recent event that you attended. Anybody else?
Sure, I agree with Rachel that the existing ground systems, were built for a reason, and they did a fine job. They selected whatever orbital regime they're working in. But today, we're moving to a multi-orbit environment. So the ground is not prepared for that. Individually, they can be, but modernizing ground systems would have to look at changing that view. Speed and flexibility are key. Security are key. Network infrastructure has to be upgraded, and ground infrastructure needs to be able to support all that. Again, flexibility and scalability are absolutely necessary, and I believe that's where things need to change.
Ken, do you have any thoughts on that one?
Yeah, and going along those same lines. I mean, resiliency, right, is sort of the big theme that we're hearing a lot of. And when you look at gateway infrastructure the way it is today, everything is very stovepiped, right? We always use that term pretty liberally when we talk about DoD architectures and even some commercial architectures. So it's very static, hard to change, hard to incorporate new capabilities very rapidly. But also, especially in today's environment, those are natural targets, right, for our adversaries when we're talking about from a defense posture standpoint. So you can take out one gateway or several gateways, then you've lost that capability. So being able to reinstantiate that capability or move it or be flexible enough or agile enough to be able to again have those continuous operations, right? So it's all about the details there when you're talking about how do you want to architect a very resilient architecture, right? And digital moving to digital is going to be key to that.
So, I mean, do you guys as a group feel then legacy systems are still fit for purpose, or are they just familiar with the operators?
I think it's both. I think that over time, like with anything, you're constantly evolving that thing in order to meet current requirements. And in some cases, the legacy stuff just stays there, and that doesn't evolve. And then that's the thing that people are more familiar with, right? And that's why it stays. So you have a lot of systems that are 20, 30 years old, and then you have systems that are newer sitting right next to it, but they're both being used at the same time. And transition is hard for users because obviously you have people who are used to those systems, but also then when you talk about there's the other piece of that, which is the tactical side or the deployed side, and that also has to be upgraded at the same time, or at the same pace as the ground system. Usually tactical does move faster, but also tactical, there's a lot more, potentially a lot more users, a lot more equipment out there that you have to touch and change. So it's a careful balancing act, and I think there's definitely both sides that sort of have to be in sync in order for an architecture to be able to transition wholly.
And Rachel, from AWS's work with aerospace and satellite teams, what tends to break down when legacy ground systems meet the modern digital workflows?
Yeah, so what we're seeing at AWS is the friction shows up in really practical ways. Changes just take too long. Security updates are hard to do without taking the system down and having that downtime. And each mission ends up with its own stack and its own data path. Operators feel that is slow onboarding of new capabilities, brittle dependencies between systems, and too much manual work to restore service when something breaks. In a contested environment, that's the difference between we operate through disruption and we pause to rebuild.
Yeah. So, I mean, as a group, you guys have touched on, the flexibility and architectural constraints, which, naturally brings us to digital IF. It has been discussed actually for years, but it's now starting to feel less optional and more foundational. So let's take a minute and talk about why that is. You know, digital IF has been around a long time. So why is it becoming essential now rather than just another design option? Ken or Ron, you have thoughts on that one?
Yeah. Uh, I'd say, it's becoming foundational now. Digital IF is becoming foundational now because the flexibility, as you mentioned, multiple orbits, more resiliency, that the flexibility that digital IF provides you uh, allows you to create that environment. New satellite systems, many of them in the new higher frequencies, Ka, Q, and V, they all need diverse sites due to weather, et cetera. Uh, Building multiple teleports to provide that diversity can be quite expensive. Digital IF allows you the flexibility to keep your gateway equipment in a data center or a central location, and then just transport the IF to an antenna location. So now you're looking at diverse sites that are just basically a small piece of land with an antenna, maybe a shelter or just HPA mounted antenna. Uh, the legacy systems, the digital IF would help you uh, modernize, optimize your RF assets. Multiple antennas in many environments are on the same satellite. You can have one in one location, one in the other, just due to where connectivity is or where customers are and they want shorter connectivity, et cetera. Well, in this new digital IF, once again, you can centralize your baseband. Even at some point in the future, we'll be talking it's all in the cloud or in a local data center, and you can have all your baseband transmit to one antenna at one location, and therefore you can reallocate the other antenna. You gain efficiencies in your equipment, hence big cost savings, hopefully. So I think it's becoming foundational because people are seeing where that's all heading, and obviously the big step is that it begins that transition to virtualization of all the ground assets.
Yeah, and I think one other thing too is that when you look at a gateway infrastructure and everything that kind of goes into it, the last everything is kind of gone digital at this point, right? You have virtual routing and switching, firewalls, you have cloud computing, so you have everything that's being changed in the infrastructure to digital, and now the analog piece, right, all the way out to the antenna, and from the modem, between the modem and the antenna, is sort of the last remaining analog piece. And yeah, and just like Ron says, I mean, it's sort of it's a barrier in order to be able to be fully flexible. To be able to move your equipment wherever you need and or restore it in the event of a catastrophic failure. So giving you that extra agility, and then removing that sort of last final piece of analog equipment at your gateway stations, so that all you're left with is just an antenna, which gives you now the ability to leverage multiple antennas when you're talking about things like pace plans and again, resiliency, service restoration, like all of that. Even also allowing the DoD to leverage commercial assets, right, and be able to connect to them quickly and securely, right, without necessarily having to move equipment forward or host it there, which also does take time, right? So this allows them to integrate into other gateways more rapidly.
So Rachel, from a cloud and edge perspective, why does digitizing at the signal boundary matter so much for, automation and scale?
Of course. I first of all agree with everything Ron and Ken were saying. Digitizing that signal at the ground station is the moment the system stops acting like a bunch of custom radio boxes and starts acting like software. Once it's digital, you can handle it like any other piece of data. You can send it where it needs to go, you can protect it, you can watch it for problems, and you can automate the workflow. For scaling, it means that adding a new waveform, sensor, satellite, or partner becomes mostly a software plugin instead of a hardware rebuild. And then for automation, it lets you automatically turn huge raw data streams into small, useful mission updates, spot issues quickly, reroute around jamming, and recover quickly after disruption. That means the mission keeps going even when conditions are contested.
Which is really important. So, we know digitizing the signal is one step. So what operators do with that digitized signal is, the next. So that's where virtualization enters the conversation, and sometimes where the debate often gets louder. So back to you, Rachel. Virtualization is often positioned as inevitable. Where does it deliver real value today? And then where do you feel it's still a little bit constrained?
I loved this question. So, as I was thinking about it, virtualization delivers value anywhere the bottleneck is speed, scale, or recovery. It lets you roll out those updates safely, add compute power when the demand spikes, and move workloads if a site is degraded. A physical ground station is a predictable target. Virtualized, rehostable ground functions can shift quickly, which improves survivability and time to restore service. The constraints are simple. Antennas and time sensitive radio pieces are still hardware, and some missions need that predictable timing. So the smart path isn't all or nothing. The smart path is to digitize early, virtualize the parts that benefit the most, and then keep those physics-bound pieces where they belong in the hardware realm. I like to think of satellite ground as your phone's operating system. The antenna is like the phone's camera lens. It's real hardware, and it's always going to be. But the value comes from what the software can do with that phone camera or antenna. And you need safe, frequent updates because the threat is always changing.
Yeah, I love that analogy. It's very simple to understand. So, Ron, from your experience with the deployed ground system, which functions realistically make sense to virtualize, and then which ones don't?
Well, I think we can all agree a 9-meter antenna is never going to be virtualized, so we won't go there. Uh, but the rest of the ground, as Rachel was saying about virtualizing pretty much anything, I mentioned earlier, the teleport is no longer just about the antenna. It's basically a data center with an antenna versus it being a teleport. Uh, having the servers on site or connecting via the cloud. As Rachel says, we can have all apps. We can have your baseband equipment, whether it's gateway, whether it's a modem, anywhere through that chain until you get to those items that in physics are not going to be able to be virtualized. Everything should be virtualized as soon as you can. I think by having your apps hosted somewhere, it allows providers to provide more vertically integrated services or allowing customers to host their apps either in the cloud or in a local server at the teleport. And they can concentrate on spinning up whatever instance they want to have at any point, and they can do and concentrate on what they do best and creating these apps. And then at the teleport, that flexibility, scalability that's now present at the teleport can be utilized. So the original question is what should be virtualized? I'd say anything that can be. It should be virtualized. Uh, and the thing we haven't talked about is operationally, the op centers, all these tools makes things much easier if everything is virtualized rather than have people running around working on hardware, pulling cables, et cetera. So, new tools to monitor, to uh, engage services, et cetera, these all need to be created, but it'll allow the operator to be much more efficient and allow the use of AI where we really can gain efficiency. So I think virtualization is just where everything needs to be.
Great. And then, Ken, as waveforms become software, what does a well-designed digital IF platform need to get right? Looking at it from a technical perspective.
Sure, sure. So, the nice thing about what we're trying to do here is that there's a framework already in place, right? And then the 5G community has already adopted kind of this network function virtualization architecture. And so, as Ron and Rachel have been saying, we want to virtualize everything, right, or as much as we can. And so, virtualizing all the functions, gives you that scalability and flexibility. But you have to remember, with digital IF, it isn't just a box or a converter. It is a system, right? Because even if you look at the current infrastructure today, it's not like you just have a modem, wired to antenna. There's other components that are sort of in the middle of that, and you have to consider that and digitize that. So you're talking about like things like splitters and combiners and switches and things like that, right? All analog stuff that you have to move to also into that digital realm. So that's really important that you have to think about. It isn't just a point to point thing. There are active components that are in the middle that other people do have to manage, right? And it goes along with what Ron was saying, and then that brings in kind of the probably the most important layer, which is that orchestration layer. So that orchestration layer, is that control layer where it is going to manage all the resources, it's going to manage all of the data flows, and also all of your traffic, and all of your general resources, right? What's available, what's not, what's failed, what needs to be changed or adapted. The orchestration piece is actually probably one of the most important parts of this whole thing in order for the system to work, but also allows you, as Ron said, to incorporate AI and real time decision making, right? And that allows you to be able to adjust the network and adapt the network to changing environmental conditions.
Yeah, and Ken, I didn't mean to interrupt you, but that's where if we don't virtualize it, these systems are getting so complex, we can't do it any other way.
Yeah. Yeah, and the thing is, there's no space, right? Analog systems are
Mhm.
huge, and they're not scalable, right? If you want to add additional capability there, there's it's usually a heavier lift. You might have to add, whole racks of equipment versus, one or two, rack units. So the scalability is just a huge order of magnitude. So we talk about, you know, OpEx and those kinds of things, that there's a severe advantage to that when you're talking about space and you're talking about floor space, power, HVAC, all that sort of stuff. That all matters right at the end.
Well, and in some industries like maritime, it really matters if you're trying to get this multi-orbit connectivity to a ship. If you're able to virtualize it, you can have a lot of different waveforms and access to a lot of different constellations on board that you would not be able to do if you had the old hardware analog methods.
Exactly. Yeah, and and that sort of translates and traverses down to the tactical layer too, right? Because it's all about, I want to carry less equipment, right? I want to do
Mhm.
more with less. And so being able to virtualize allows you, like you said, carry multiple waveforms with you on a single computing engine. Or even, being able to reach back into the cloud and leverage the cloud more, even at the tactical layer. So those sorts of things are fully enabled when you have a fully digital and virtualized architecture. So it creates a whole new market where it opens up a lot of
Yeah,
possibilities for technology and what can be done all the way down to the user level, right?
great. That's good. So, you mentioned, technology. So we know technology decisions really don't happen in isolation. There are tied to budget and timelines and truly the operational realities. So let's talk about what modernization actually looks like when economics are really driving the conversation. We know ground operators are under pressure to do more with less. So, from an economic standpoint, what modernization strategies make sense right now?
I
Yeah, so
I
from
think.
my
Oh,
oh, go ahead, Ron.
go ahead, Rachel.
Well, I was going to say that the most affordable modernization is step by step. So keep the RF hardware that's working, digitize what you need to digitize early, and just upgrade the software pieces over time without shutting the mission down. Standardize and reuse the basics. You're not rebuilding from scratch for every mission. This reduces operating costs and improves readiness at the same time. And then I think we need to talk about how you measure success. I think judging progress by simple results like how fast can we recover from a degraded status, how fast can we update, and how much manual work did we remove? To your point, Ron, you've got people running around doing manual things on site. How much of that can we cut out? Those are the benchmarks of success from this.
I agree with a lot with pretty much everything Rachel said. I think, you know digitizing, you may have to start small. It's not going to be a cheap endeavor. A teleport is not cheap. So go ahead and start virtualizing certain things, creating those services, uh, migrating older services onto that new as you can, depending on what works for you. uh, I think slowly but surely you have to get down to that, and to provide the correct tools. As I mentioned earlier in the conversation about multi-orbit, if you start virtualizing services, to Ken's point, with network function virtualization, we could be watching, traffic, what type of traffic could go, what's better on LEO, what's better on MEO, and you can really create services that are, you know, very efficient, by putting them on the right orbital regime so you can be using what you're using. So I think as people look at those services that they're building, they have to virtualize onto that. And to Rachel's point on the transition, it's definitely going to be slow, relatively slow. You're not just going to forklift. It's much too
Yeah.
expensive, much too dangerous. So I think a good plan of modernizing your facilities, modernizing the types of services you offer, training up for this. Uh, the SATCOM world has a bunch of RF knowledgeable people, and not as much IT, compute, developers, et cetera. I think people have to look at that as well on hiring new skill sets that would help run these types of systems. Um, so I think the point, I'm just going to beat it to death here, is virtualize what you can and then create a plan to slowly migrate to the new environment while also paying attention to where you want to go with this, because that's going to be the most important part, that you end up where you need to be in a new environment.
Right. So rip and replace really isn't realistic based really on economics. So how important is, backward compatibility when operators are investing in these, new ground investments?
I think for this to go smoothly and as quick as possible, there has to be backward compatibility. Again, just to do that transition, there has to be some backward compatibility, because some customers are not going to change. If you have contracts with people and the old model fits their needs, and you're not just going to shut them off. So having that backwards compatibility to allow you to migrate them on as well, and then show them what new systems can do, and then maybe you can upsell.
Okay. So can, at ATG Solutions as CTO, how do you design a platform like iFlex so operators can modernize incrementally instead of, as we mentioned, ripping out their entire ground system or even disrupting some live missions?
Yeah, and what's great about this technology in general, and kind of how our approach and how we've designed kind of our iFlex family of products is really about being able to install this in parallel to your existing systems, but also start out small and then be able to easily scale up, right, with very little lift, right. It's just really just a matter of adding more boxes or more equipment, but you can get a lot more capability, right, because you have a lot more density, right. Our iFlex box has one of the highest channel densities per RU in the industry when you talk about a digitizer. And so, the putting in a digital IF infrastructure in parallel with your current infrastructure, it's very transparent both to a user and also even from a gateway architecture perspective, right? Because you're just sort of replacing the transport piece, but your modem and your antenna and your RF stuff stays the same. So that's nice and that stays familiar. But the path to get there changes, and but it is relatively transparent, and you can start small, right? You can start as small as like 4 RUs of equipment, but still get a lot of capability. And then all you're really doing is you're just, if you're using and tying this into your legacy modem architecture, all you're really doing is you're just moving a cable from a modem, off of your patch panel to your digitizer infrastructure. So it's a very easy switch once you have the equipment installed, and it is again it's transparent to your end user, and then it allows you to run both systems in parallel, so that look, if you do run into a problem, you always can revert back to your analog infrastructure, but then you can start slowly incorporating and using your digital architecture, and like Ron said, you're building your capability, you're building your skill set, you're training, and so you can train in parallel, right? So you can keep your analog infrastructure. That's we understand that, but then you move to your digital, and then you can cross train there while adding capability, and then starting to move transition missions over. And then if you want to add more capability, more capacity, you're really just adding more servers or more digitizers. More of the same equipment, and it's a lot easier to upgrade, a lot easier to scale up very easily, and it significantly saves you on space. Like I said, you can, do what you're doing in several racks into just a few RUs within that. So that's a huge deal when you're talking about that, and then being able to just again upgrade and add capability without having to do a major overhaul on your architecture infrastructure is a huge deal as well.
So we've talked, about today's constraints, right, and the realistic paths forward for operators. So I'd like to close by taking a look ahead. Starting with you, Rachel, 5 years from now, like what architectural decisions made today will matter the most, regardless of the vendor or the platform?
Yeah, so I think the decisions that will matter most are the ones that keep you fast, resilient, and interoperable, even as vendors and constellations continue to change. So digitize at the boundary, decouple the hardware from the software, design for continuous updates, bake in that identity for security, standardize those interfaces for coalition operations, and then, like we talked about earlier, measure outcomes like time to restore and time to upgrade. I will say this is a really exciting time to be in this SATCOM space. Everything is changing so quickly. It seems like every few months there's, a major update to what constellations are coming online. The compute architecture enables things that were not possible 10 years ago. And like both Ken and Ron talked about, artificial intelligence is changing the game, and there's a huge role for it to play in this exact space once we have everything virtualized. So I would just encourage everyone. It's such a fun time to be a SATCOM engineer.
Yeah, and Ken and Ron, do you have any thoughts on that? I know I was going to direct that question to you, but I was just curious if you have any thoughts on that one as well.
I, uh, I would say I agree with everything Rachel said. It's exciting. There's a lot of things that are changing, a lot of things that are happening today that we'll see 5 years from now, and a lot of thought and engineering and operational thoughts need to go into what's going to happen 5 years from now. Uh, Kind of jumping into where we're heading on some of these questions, I would just say like the challenge I don't even know if the challenge is going to be the engineering or the operational side. There's a lot of smart people out there that are looking at this and devising ways to do it. I think the bigger challenge is the mindset uh, of the team on how to transition, when to transition, the business case. I think economically, it's the industry is known to want to milk every asset they have for as long as it is. It's a highly capex environment, and people have spent a lot of money, and they want to use it the best they can. But in the modern environment, if we're going to see 5 years from now what Rachel explained, then you have to modernize, and to modernize is a lot of money. And the business case, like I said, engineering operation, you can figure it out and you can get costs. It's going to be those other costs where you sit there and say, okay, if I'm more efficient at this, how much am I saving? Is an OPEX model better than a CAPEX model? How do I go through that? What efficiencies do I get? And it's a tough game because you're guessing on a lot of that. And I think the people that get most creative and maybe take a larger leap of faith that this efficiency is really going to get them where they need to go, they'll be the ones that transition faster and be the most successful. And while Rachel said she'll be agnostic on naming people, the vendor or the question was, regardless of vendor, I think the vendors and the operators that jump into this and realize that it is a change game, that they'll be ahead of everybody else. And if you don't, you'll be left behind.
Yeah, and I think it's important to also don't overcomplicate it, right? So when we digitize and virtualize, right, we're moving into that realm that is pretty mature, right? That sort of IT sort of realm where you're moving packets right around, and I think it's important to not try to overcomplicate it too much. Digitize everything, but incrementally add capability, right? Don't try to make it perfect the first, coming out of the gate, but sort of just add incrementally, right? That's really where I find most successful systems have are successful, right? Most systems have become successful because they are able to incrementally evolve based on current needs, and so trying to not overcomplicate it is I think going to be really key. But yes, again, uh, I think the people who are going to adopt it the fastest are going to be truly going to be driving how this shapes out, how what the architecture is going to look like, what capabilities are going to be put out there first. So that's definitely important as well.
That's good advice. So, just to close things out here, what from each of your all's perspective, and Ken, you may have just touched on this, but what's one practical piece of advice you'd give operators facing ground modernization today?
Would say it's pretty simple. We've been saying it all along. If you haven't started planning for virtualization, you better get started. If you did start, you better go faster because there's a lot of people that are getting there already.
Yep. Rachel, Ken,
Yeah,
any thoughts?
there's going to be hardware that's nearing the end of its life. So make sure to look at that and figure out a plan for what comes next. And then try to figure out, what is your plan? What are you going to do in 6 months? What are you going to do in a year? And don't be afraid to just get started. Um, One of the gaps that Ron pointed out, there's a lot of really smart RF engineers and people who know this SATCOM hardware, but maybe there's a gap with cloud expertise. I just want to encourage everyone to reach out to your hyperscalers. They have solution architects and resources that you can lean on to build that knowledge on your teams. And they can help find partners too that can help do some of this. You're not alone. I guess that's my my one main thing is use the ecosystem.
Yeah, and that's the thing. I mean, I think that the thing is that like Ron said, this is coming down. This is coming around the corner. So uh, you want to embrace and adopt it, and then really kind of help drive where this is going to go, where the technology is going to go. Because like people are still, obviously this is still emerging, the technology is still emerging, but people are finding new uses for it. People are finding new applications, and also based on where our technology is today, using that as sort of a framework for like where this could go in the future. So I think there's a huge huge potential for this technology, and a huge potential to really transform what your gateways could look like, what it could do, and what kinds of additional capabilities and services that you couldn't do today are going to give you that sort of advantage, right? Both from a network capability standpoint, and also a competitive advantage too.
Thank you, Rachel, Ron, and Ken, for the great discussion today. As you all know, ground architecture does not change overnight, as we've heard, but the direction is clear: more flexibility, smarter economics, and integration of systems designed to evolve instead of just being replaced. So, if you want to learn more about the iFlex platform and how it helps operators modernize ground infrastructure without locking themselves into proprietary architectures, visit atg.space. Thanks for listening to Conversations with ATG Solutions, and we'll see you next time.